great to see some familiar faces, but really so many people that I've never met before. So really excited to share my work with you today and maybe inspire you to think about some things in your own work as well. Just as a brief introduction, in case you don't know me, I'm an artist. I teach at the School of the Art Institute of Chicago, and I just defended my dissertation 3 days ago, and so I'm now a PhD. In 2012, I found myself obsessively collecting hairs, chewed up gum, and cigarette butts from the streets, public bathrooms, and waiting rooms of New York City. It all started in a therapy session when I found myself sitting for an hour and staring at a print on the wall, and then noticing that the glass covering the print was cracked and that there was this hair stuck in the crack. I found myself imagining the patient, who must have had long, dark hair, sitting on the couch, leaning back, and getting that hair caught. It's something I'd done countless times myself. I related to this person, this stranger. I wondered who they might be and what they might be like. And when I left, I just couldn't help noticing these things all around me. Cigarette butts and chewing gum on the sidewalk, hairs on the subway bench, saliva left on the rim of a coffee cup. I started seeing evidence everywhere. And it occurred to me that the very things that make us human, hair and skin and saliva, the messiness of the human body, become a liability as we constantly face the possibility of shedding these traces in public and leaving artifacts which anyone could come along and mine for information. And so that's exactly what I did. In Stranger Visions, I collected those hairs, chewed up gum, cigarette butts. I extracted DNA from them and analyzed it to generate 3D, life-size, full-color portraits representing what those individuals might look like based on genomic research. When I began this project, it was a natural progression from the work I'd been doing with machine learning, looking at electronic surveillance systems like speech recognition and face recognition. This background gave me the conceptual perspective I needed to see the problem and the technical tools to experiment with making it visible. But as I worked on this project, I began to research deeply for my dissertation, and I found that the emerging technology I was pointing to, which is called forensic DNA phenotyping, that's the generation of a phenotype or an appearance from DNA alone, that this practice had problematics which extended well beyond the issues of surveillance. What I learned doing this research was that DNA phenotyping relies heavily on the creation of categories. We've talked about a lot of categorization here at this conference. It's based on a process of building up a data set of 3D facial scans and DNA samples taken from research volunteers. These scans are processed to create what's called face space, a probabilistic space representing all possible faces drawn from and limited by this set of 3D scans. So this will be familiar to anyone here who's worked with facial recognition technology, this idea of creating a face space of possible faces. And finally, that data is mined for correlations between DNA and facial characteristics in ways that align with preconceived dichotomies of possible traits. And that's really key. It's about this preconception of what those dichotomies are. So things like male versus female, old versus young, heavy versus light, and most troubling perhaps, European versus African. The act of creating computational averages and looking for correlated features in large data sets has an air of authenticity and scientific validity to it. But what it actually does is create a system of types, which are essentially stereotypes. Facial compositing is not new. It goes back to Francis Galton, cousin to Charles Darwin, popularizer of the fingerprint as an early biometric mode of identification, and infamous eugenicist. In the late 1870s, he used an early photographic approach to facial compositing to discover typologies in large data sets of photographs, many of which were collected from the police. And so he discovered types like the violent criminal, the thief, the diseased, and the Jew. He also used this technique to find ideals, the norms against which deviance could be judged, ideal types like scientists. In 2012, I based the research for Stranger Visions on published research that I was founding, and then I forecast where I thought that technology might be going in the next 5 years. In December of 2014, a company called Parabon launched, offering essentially exactly this service to police. So look closely, or as closely as you can, given the wonkiness of the screen here, look closely at this profile that this company Parabon is offering at great expense to the police departments around the country. What do you see? Anyone? Any reads on this profile? I don't know how well you can even see it. I can't see it at all from over here. Any thoughts?
A lot of the information is like characteristics this person doesn't have. So it's like
That's interesting.
not very fair and light or all these like not categories.
That's cool. It's a good observation.
Could you repeat the comment?
The comment was that there are a lot of nots here. So it's saying this person is not this and not that. Any other observations? I mean, what's the primary way in which this face is being created? What's the main piece of information there? There are a couple, but...
It's giving us a fairly generic profile of a black person.
Yeah, exactly. This is a generic picture of a black man. This is what Parabon considers to be a generic picture of a black man. So sex and ancestry being the two main parameters along which these faces are morphed, basically. Okay, and so just in case anyone doesn't know this, race is socially constructed. This means that there is no biological basis for categorizing humans into types like white and black. Black and white take on meaning in human communities. There's no gene or set of genes that code for black or white. These racial concepts are human-defined constructs with political histories that vary regionally and shift over time in accordance with cultural views, including the popular science of the day. Parabon's work is, of course, closed source, trade secret, but when you look at their promotional materials and study research papers published in the field, it's fairly clear how the technology works. And it relies, as I've already been getting at here, on some problematic assumptions. So the assumption that identity is biological and that characteristics like gender and race can be read from the body, quantified with percentages, labeled as typologies, and transformed into visible characteristics. The assumption that a set of stereotyped representations of race and gender will be universally recognized as reflecting the categories assigned by their designer. So the issues at stake, the likelihood that forensic DNA phenotyping becomes a new form of seemingly scientific racial profiling, which serves only to seemingly legitimize the biological basis of race, is very real and I think very pressing. If things keep moving in this direction, it's entirely likely that within the next 5 years, phenotypic predictions will include an even larger swath of dubious scientific traits like sexual orientation, likelihood of being a smoker, religious and political preferences, and maybe even surnames. So unless the public steps in and voices their dissent, there's very little regulation that can prevent companies from offering dubious forensic services and law enforcement agencies from purchasing these half-truths. So while Stranger Visions began for me as a project to make the invisible risk of surveillance visible, it has taken me into this new direction as well to attempt to excavate these kind of hidden stereotypes that are built into the structure of so many of the tools that we use every day as black box algorithms. And if you want to read more about the details of my critique of this technology, you can check out this article that I wrote for the New Inquiry called Sci-Fi Crime Drama with a Strong Black Lead. This is also a chapter in my dissertation, which I hope to publish in the next year. So just a slight new direction for this project for me. In July of 2015, Paper Magazine contacted me. They were planning to publish an interview conducted by mail with whistleblower Chelsea Manning, who's incarcerated in a military prison and cannot be visited by journalists or photographed. They wanted an image of Chelsea to accompany the piece that they were writing, and they recalled my work in Stranger Visions. After asking Chelsea for her approval, they emailed me asking if I would be willing to create a portrait of her from her DNA. In case anyone has forgotten, Chelsea Manning was arrested in 2010 as Private Bradley Manning, an intelligence analyst for the US military in Iraq. She was arrested for making information public through WikiLeaks exposing the prevalence of torture and civilian deaths in the Afghanistan and Iraq wars. Incarcerated since her gender transition and rendered invisible to the public due to a prohibitive policy on visitors, no one except her family, old friends, and her lawyers has actually seen Chelsea Manning. She's literally been made invisible, disappeared from the public eye. So the first version of this piece, it's called Radical Love, was virtual and was printed in Paper Magazine alongside the interview, and it consists of a diptych of portraits to represent Chelsea. So you can see here, one of these portraits has a algorithmically, quote, neutral gender, and the other is assigned a female parameterized gender. And so my hope is that the exhibition of both of these possible faces side by side draws attention to the problem of utilizing biological sex to assign gender, as well as the larger issue of relying on stereotyped ideas of what a gendered face is supposed to look like, right? How do we define what a female face is? The 3D prints of this work premiered at the World Economic Forum in January, bringing visibility to someone who had been made invisible in one of the most inaccessible events of the year. So to wrap up a little bit here, forensic DNA phenotyping is one algorithmic technique building on enormous data sets becoming available, but machine learning more generally builds its smarts from the creation of norms, typologies, and structures discovered or trained through the careful selection of examples. Once a system is operational, this training essentially disappears. The user doesn't know about the curation of the data that went into it or the implicit categorization it supports. Algorithms are political. To work with algorithms is a political act because the material itself has such tremendous impact on people's lives. We as programmers can have a profound influence. To ignore these politics is to tacitly reinforce the inequalities of the status quo. And so I take this as something that I aspire to, and I put this forward to you as an invitation to practice. Let's open these black boxes. Let's expose their guts. Let's question them, critique them. Let's use our algorithmic work to challenge the algorithms themselves, and let's subvert the status quo. Thank you. I'd love to follow this with a little discussion since we have some time, so I'm happy to take questions or more informally sort of chat. Any questions? Can you turn the lights on so we can see?
There's someone in the back.
Yeah, middle.
What other algorithms or areas do you think need their best exposed? You mentioned surveillance and probably a hot one, but wondering what are others?
That's a good question. I mean, I think I've been, anything that involves a typology around humans, so I think biometrics and anything involving the face or bodily recognition, anything that involves identity, those are kind of key areas to hone in on, I think, because there are places where categorizing people can then reshape how we think about these categories ourselves, reshape how we understand our own identities. So anything around that, definitely anything in the area of genomics, microbiome, anything with DNA that is looking also at identity. Good places to start. Yeah.
Since you've mentioned that these are available to police now, are there any high-profile cases where the police have said, "Hey, we used this and it worked," or cases where they were tried using it and it was a failure and they tried to cover it up? Or the other part of that question is, have you seen maybe in pop culture, like on Law and Order or any shows along those lines, where a technology like this is used and sort of discussed in that sort of manner?
Okay, so for the first one, a number of these profiles have been produced by Parabon in relation to unknown suspects, and to my knowledge, it hasn't helped solve a single case. Although, yeah, sort of the definition of that might be questionable. On the other hand, I do think that there's a really positive use for this technology in looking at unidentified remains. So I never would say that any technology is, I mean, well, maybe some technologies, but this technology in particular, I would say it's not that it's all bad. It's just that using it in this way is potentially really, really bad for a big portion of the population who's going to be subject to increased harassment because of it. And so it's that implementation of it that's really problematic, whereas using it to try to bring some kind of data out around unidentified remains could be really useful. You know, could be just giving some kind of clue where, you know, the accuracy doesn't pose such a big problem if it turns out to be completely wrong. And in terms of pop culture, I haven't seen it in pop culture yet, which is, well, except for the Hong Kong litter campaign, which was where an ad agency took the idea of stranger visions basically and then applied it to Parabon's technology. So they claimed to be publicly shaming litter bugs in Hong Kong by picking up their cigarette butts and creating portraits of them and then putting these posters around the streets to publicly shame them. But it was a total scam. I mean, they didn't actually do it. They just worked with the DNA of people who were already working on the campaign. Yeah.
So you mentioned that there are no laws regulating the use of this technology, or for that matter, machine learning, which is really profiling, essentially automated profiling. What sort of form do you think regulation could take? Because it can, like you say, be useful in some instances.
Yeah. Okay, yeah, so what form could regulation take? And that's a really tricky question. I think we need to have some form of regulation around what the police are allowed to do in investigating crimes, because right now there's absolutely nothing, right? So they can use a psychic, they can use this DNA phenotyping, like there's absolutely nothing other than their own budget that limits what they can do. And so there needs to be some oversight of that, right, where you have people who are invested in these issues contributing to that. Was there another part of your question? Or was that it? The legislation? I mean, I guess I think
What sort of rules
there's sort of like three things I think we need to do around these issues, because policy reform is only going to take us so far. So I do think we need some kind of policy reform. But then there's also a big issue for us in education, right? Those of us who are teachers in this room, and probably a lot of us are, right? Even if teaching is leading a workshop, introducing these kinds of complications when you're teaching about these subjects is so important. Introducing this as a critical practice and not just as a, you know, fun or cool kind of practice, I think is really important. And so that's another area where I think we have a lot of agency. And then cultural norms are another one. So just getting the messages out there, just sort of pushing it to the public that these issues do exist and that we need to be thinking about them differently, I think is another major portion of that. Anything else? Oh, on this side. Yep.
Do you claim copyright on the scans that you produce of these individuals, especially from the found materials like hair or gum, in terms of if you're making a practice, or do you open license those?
I'm neither.
Yeah.
Yeah, so moving towards the back.
Your 3D prints are all stripped of any kind of affect, or what we might call affect. And I'm wondering if you can talk to that as an artistic choice in terms of displaying those affectless renderings.
Yeah, okay. So okay, sorry, yeah, so the observation was that the portraits, the 3D portraits, and I'll just go back maybe to them so we can see. what they look like here, that these are affectless. And is that an artistic choice to present, sorry, it's right here at the beginning, to present these portraits stripped of affect? So there, I think that's a really great question, and it is an observation that gets back to the model, right? Because these faces are produced from 3D scans of people's faces. And so the kind of neutral face of the model is the neutral face that the research participants were asked to adopt when this model was originally formed. This is based off of an open source 3D morphable model that came out of Basel. It's called MorphFace. So anyone can go download that and play around with it. You'll see that if you do download MorphFace and play around with it, what you'll see is that it's based on a data set that looks a lot like this. And so if you want to represent anything, anyone who's not white, you'll have to retrain it with different images to allow that to be possible. Yep.
What's your stance on how to unopen the black box? Is it a matter of simplifying complex history, or is it a matter of pedagogy in terms of educating people how specifically how this works? And I guess in terms of this kind of spectrum of pedagogy versus implementation, where do you lie as an ideal balance of, teaching people generally about how this works versus the specifics of how specific algorithms work in specific ways?
Okay, so the question is really about how to open the black box and how to teach about doing that, I think. So I think ideally it's a complex of different approaches. So I do think it's really useful if people have a kind of basic technical understanding, right? Basically can understand how to program, what an algorithm is. That's a basic technical literacy is really, really important. Not necessary, but really useful. And then I think it's also about, so for example, when I teach my students about this kind of practice, so I do a workshop with my students that I call a genomic identity workshop. And we work with found genetic profiles that we download from the internet, and then we interpret those in different ways. And then as we're going through that workshop, as we look at different techniques for analyzing these profiles, we're also reading critiques of the technologies that we're using. So we're sort of using technologies, but also understanding that they have these limitations and biases, and that they might be colonialist, or they might have other kinds of issues that are going on with them. And so I think that if you can try to introduce things in that way so that the complexities are visible, that can be really helpful. And then and then sort of more broadly, I think it is an education. It is a task for education, but I also really think it's a task for us as artists to do this. So I think that there's a lot that we can do in our practice to expose what we're doing with these algorithms, or to push the algorithms in ways that expose these things in the project themselves. So like where you take the technology with the project can then reflect back on some of the issues with that technology. So it's just sort of like using it self-reflexively, using the algorithm to critique the algorithm itself. Back.
So you need to supervise really needs to policy really have to do it. The unsupervised, of course, there are obviously lots of stuff, but I think it makes it harder for people to get. I remember during the algebra games, a lot of people would talk about it, all those things. The weird the algebra has to be this. A lot of people were very fixated and want to look at the black box and wondering what are the issues of trying to educate people. I think those kind of things like deep learning, people don't want to look at politics. How do we get people to just talk about black box and say, it's very complicated, we have to investigate that. I feel more and more others are getting more complicated. People see wanting action.
Yeah. So one example of that, I'm just going to tie it back to the stuff I've been looking at here. So they're clustering, right, is an example of politics what can be seen as politics in an unsupervised situation, learning situation. And so there is a data set that has lots of different DNA from ancestral populations around the world, and then this data gets clustered, and then that clustering is used to reinforce the idea that there's like a 4-continent model of ancestry, and that we can just decide what people's ancestry is based on their DNA because they fit into this cluster, and this was just found. We just discovered this cluster in this data. But the way that that data is collected, the way that it's interpreted, the number of clusters that are found, I mean, there's so many things that go into producing the data, curating the data, arranging the data, deciding on the parameters of the system that get hidden, really, when we talk about things in that way. So I think just the fact that most of us sitting in this room know that algorithms are made by people, right? And that there's all these decisions that we make in using them that do get hidden. Like that alone is so important. And so just bringing that subjectivity out, I think, is the first task. So, I mean, a lot of this stuff, you know, if you're interested in this, come talk to me, because I'm definitely looking for collaborators, and I'll be in New York next year working on a new project. And I think there's so many areas here that would be really useful to dig in deeply with the kind of technical expertise and artistic interest that people in this room have. Okay, last question.
You mentioned briefly that like training data has the potential to be biased, and I was just like sort of like thinking like in my own life, I'm from Hawaii, and like probably a lot of like the cultural objects and like the flora and the fauna of like my life probably don't exist in a lot of these training sets. So I was wondering if maybe you could expand upon a little bit, if you have some ideas about, I don't know, maybe like accounting for like bias and lack of representation and things like that.
Ideas for accounting, accounting for bias and. Yeah, no, I mean, I think just talking about it is a good first step. Like, so just pointing out that there is bias in this training data, and that, you know, to make a morphable model of a face that's all white people is not okay. Like, that's step number one, right? And to point out, like, oh, your model of fruits doesn't have this fruit from where I'm from. You know, that could be maybe a slightly less loaded thing to take on as well. But really, I mean, it ties into these much larger systemic problems about who is making the models, right? So if we have people of more varied backgrounds, if we have more women and people of color making these models in the first place, then these things won't, I think, be as likely to be overlooked. And so maybe that would be a good point to end on, just that we desperately need more diversity in computer science and machine learning and AI, and in the intersection of those things with art. Thank you.